जो आज का जो टॉपिक है that's related to data quality is the background is a bit just want to give a quick background why I chose this. So in recently, like with the advent of big data, there is a shift happening in the world of big data things. So initially, people were involved in data warehousing or business intelligence reporting. उनका एक process था, एक definite एक process चल रहा था कि जी you get the data from there, you define the ETL pipelines, and then आप एक data warehouse बनाते थे, and then उसका एक fixed schema होता था, and then your ETL pipelines या source से data लाके उधर उसमें process करती थी and or transform and then write it there. उसमें जो मेन इश्यूज आते थे, वन थिंग बिकॉज आपका एक स्कीमा जो था वो ऑलरेडी डिफाइन करना होता था, दैट्स द इन योर टारगेट वेयर हाउस, एंड योर ETL पाइपलाइन हैज़ टू कन्फर्म टू दोज थिंग्स. तो वो एक टाइम कंज्यूमिंग प्रोसेस था. उसमें द लॉट ऑफ इश्यूज इन्वॉल्व थे, एंड देन ओवर द पीरियड ऑफ टाइम जिस तरह हमारे पास चीप बिग डेटा सॉल्यूशंस लाइक Hadoop और other Azure, the people have moved from this model to a different model, जिसमें instead of defining the schema of your warehouse, like firstly you basically you can dump the data as in a raw format in Hadoop or somewhere, and this model को इसमें the फ़ायदा ये था कि जी जो आपका एक initial एक schema design करने में time चाहिए था, you have to talk to different teams and understand the requirements, then come up with your warehouse schemas and facts and all these dimensions and things. तो वो एक effort जो थी upfront effort आपकी वो that's reduced हो जाती थी. And this thing basically 8 years ago when Hadoop started market में others use होना शुरू हुआ, this thing basically really kicked off because basic idea ये था कि जी आप source से data in any format आप लेके you can dump it in Hadoop in Lake. The other difference was that जो आपका warehouses थे, they only support relational data, right? Whereas like in Lake, you can have a structured data like the relational one, unstructured like images and stuff like that, or mixture of semi-structured as well as like your JSONs or stuff like that. So this thing really kicked off, और उसमें फिर a lot of possibilities arises in the big world of big data. इस मॉडल में प्रॉब्लम ये हुई कि इनिशियली तो ये बहुत ज़्यादा सक्सेसफुल रहा, या लोगों का ये प्रॉब्लम्स हमारे बहुत सॉल्व हो गए, पर as the data gets into like more and more data gets into the data lake, उसमें प्रॉब्लम ये स्टार्ट हुई कि जी डिफरेंट यूज केसेस हैं इस डाटा के, राइट? मशीन लर्निंग टीम ने डिफरेंट केस यूज़ करना है, and business intelligence teams जो reporting कर रहे हैं, they have different requirements, and then other teams like say अगर compliance की teams हैं, उन्होंने real time reporting करनी, तो they have different requirements. And a problem भी होता है कि because this is unstructured, किसी modeling नहीं किया, how would you what would you do? So basically what people start doing is each team basically goes into the lake and create their own copy of the data and then start working with that. इस पर प्रॉब्लम ये हुआ कि जो हम the governance का जो issue है, मतलब how would you assume the quality, like people started कि where would they find their data in the lake? This is one of the issues that rises कि for example, if I want to find a golden truth of the data in the lake, where would that truth lie? Because there are several copies of that data available. And then people started realizing कि जो old आपके governance के models थे, जो कि आप जब when you create a warehouse, those are really needed. And then basically जो एक area जो data governance का sideline हो गया था, people started realizing that that's needed for big data lakes as well. And then basically this is where all this started, and recent like 3-4 years ago, people like companies Google, IBM, they come up with several initiatives to solve these issues. They come up with open source toolings and to modify the existing data governance frameworks, come up with new things in there. So this is kind of an evolving area, kind of a hot area as well. And then now what we are seeing now is people. There is a new concept called lake houses. Like people have now moved on from data lake to a new form of data lake called lake houses. जिसमें governance is an integral part of the data lake. For example, there is a particular Apache Hudi, which is used in Walmart. Databricks is called Delta Lake, and to some extent, Azure Synapses is actually kind of an implementation of this lakehouse concept. But let's go back to governance. So one of the fundamental things within the data governance is the data quality. So the first question is, how would you define data quality? And the problem is there is no single definition of data quality, because it's to different people it means different things. So what I did is Wikipedia पे जाके, let's say I said I looked at a couple of definitions. Like the two prominent one are a data basically is considered of good quality if it's fit for its intended purpose of use, or the other one is like the capability of the data to satisfy the business and technical requirements of an enterprise, right? So let's go back to the first one, that if the data is fit for intended purpose of the use, and if you look at this definition as well, so it's maybe context. What is fit for purpose? Like, how would I say is it fit for purpose? So if you ask me, like, if I'm an end consumer of the data, then from my point of view, if the data I'm consuming, right, if fulfilling my requirements, jo bhi requirements, and then basically for me it's a good quality data because it is doing what I want it to do, or it is giving me that information which I wanted as a consumer. But if at the same time, if someone from the business perspective, like as a business organizations which want to use the same data, maybe for operational or planning or some other purposes, operational planning or reporting purposes, that data might not be fit for their use. So so this is where basically the thing is the fit for purpose basically is again contextual, right? So depending on which context you're talking about, so data can be fit for an end consumer perspective, but not for the business organization perspective. So it's basically what you do is from each perspective, people like define their own requirements, right? So so what is those requirements? So what we're essentially saying is, I have a data like in a source format, right, in form A, and this is my desired form, right? That what I want it to be in, so that it's fit for my use. So this is what we're actually doing is what is quality. Data quality is actually, we are basically comparing the actual set of data with an intended or a desired state, right? So this is what actually when people talk about quality is what they are actually talking about, because depending on the context, like we are talking about data is this form, and is it meeting my requirements, which is like my desired state. Like if meeting my requirements, like, and then it is good for use. I think next thing is as I mentioned, there is a desired state, right? We want to define requirements for the desired state of the data, right? So how would we define those requirements? So normally, what you have is you look at certain characteristics of the data, right? For example, like let's say आपके is entity है, उसके अंदर you have entity, like for in terms of like a table hai ya customer ki entity hai, there are several elements in that entity, and then you define certain characteristics of those data elements with that entity, right? And these basically वो characteristics जो होते हैं, the requirements of your desired states are defined in terms of those characteristics. And those characteristics are basically, like say, I want uniqueness, right? I want validity, right? I want completeness, matlab non-null values. These are the characteristics of your data elements, right, which you define. And these basically characteristics called data quality dimensions. And then your requirements, जो आपकी quality की requirements हैं, you define them in terms of these characteristics. So let's look at like some of the basic characteristics. So there is a body data management or a global body called DAMA, Data Management Association, and they have defined like there are several data quality dimensions, but the 6 main ones they have defined are accuracy, right? So what accuracy means, like if your data, is it representing the real world values? For example, I give examples. In case of a product or a person, is their name, the spellings are correct? Yeah, addresses are representing the real world values. Similarly, completeness, I mentioned earlier, are all the values present, so there, which means there's no null values in the data. Consistency is data is representing consistently across all the data sets you're looking at. It means like, for example, आपने अगर you have definition account customer का कोई अपनी let's say you have defined an ID to that, so that the same ID is used across all the assets, so that you can identify them. Or in this case, the example is कि customer का account जो है वो closed हो गया, but still there is an order, a new order basically उसके account closure के बाद associate हो गया था. So these kind of thing. Timeliness is basically you look at the how old is your data, and right, for example, अगर आपके पास you have a 12 months old data, it might be useful, useless for your use cases, because it has changed, things have changed in a 1 year time. So this is timeliness as well. The other two is like uniqueness, means only if is the data element is already is recorded only once in the system. And validity, which means like you define some format for data, or is the data conforming to that specified format. So basically, these are the 6 main characteristics होती हैं, just in terms of that you define your requirements for the data quality, right? Or you define your the desired state of your data. There are other dimensions as well. Basically, I gave a link as well, so if someone wants to look more into what other data quality dimensions are available, they can follow that link. One is like there is a DM book, quite big, version 2 book. People can look into that for going more into. And then there is this standard as well for master data management as well, and they have defined certain like other dimensions as well. So coming on again, continue with the dimensions thing. So this is kind of an example, right? The same thing, completeness. So you look at this address 1, 2, 3, and 4, right? So you can see it's the addresses, like you can't make any sense from that, right? So it's just a street address, but no zip codes or anything like that. Similarly, conformity, which is like again validity. You can say it validity as well, where it says the phone numbers, like they are stored in different formats. And consistencies means again is the same information used. So for example, here example is the transaction ID. It's the same transaction ID, but it's assigned to two different customers or orders, right? So something's not wrong here. Similarly, accuracy of the data, basically, again, the example is address, like the address is again incomplete. You can't make any sense from this. Duplicate is the same thing, right? Duplicate, everyone knows that. And the integrity or is again, are we trying to reference a data which is missing or stuff like that? So these are kind of data quality dimensions or characteristics which normally people use to define the requirements of their data quality. Next thing is I mentioned like the data elements, right? So so when you want to check the quality of your data, right? So you are basically looking at tens of thousands or maybe hundreds of thousands of data elements like in your data sets, right? So the question is, where would you start, right? I mean, ideal state is कि आप सबको check करें, but that's not humanly possible, right? So business size possible नहीं है. You have to start from somewhere, and then if you start looking at like अच्छा मैं पूरे I'll look at all 100,000 data elements which like in my warehouse, in my lake basically. So that will take ages, right? Because it's a time-consuming process, right? So you have to start from somewhere basically, and what people or like even the DM Walk book suggests as well, that you start with the elements which are the critical for your business success, right? So so some of the critical elements, so the one of the easiest way is that maybe if you look at the existing reports of your businesses, then they might be, for example, if I'm looking at the sales report, right? So there is a report which the total sales of my company, right, is an important element, right? So that I can start from there. So I can say I can define the sales value of my yearly sales value or sales of my company is a critical element. So I look at that thing and then I go backward and trace it all the back to the source, right? So if I look at the company-wide report, then that information is coming from department sales as well, right? So I go back and look at the reports for the departments and see my company sales is coming, like the company sales value is coming from these reports, and it's depending on these elements within these reports. So I'll mark those elements in the department's sales as critical as well, and then I go back until I reach the source, right? So this is kind of just an example, right? So basically the idea is that instead of looking at starting big, like looking at all those things, you start looking start from defining your critical data elements and basically define quality requirements for these things, right? So you start small and then basically make sure that the process is working, and then basically grow from there. And the good starting point is the critical data elements, right? So anything which is critical for the success or to get the job done, basically in an organization or in a process, can be considered as a critical data elements. And again, basically, these critical data elements basically they vary from business to business, department to department, right? For example, just I mentioned, sales for a sales department, it might be different thing, but for the compliance, they're interested at two totally different things. Right? Their in BI reports will be different, and uh, uh, their interest of area of interest, like in the data, will be different. So these CDEs are basically they are not generic. They are actually business area specific. So that's one of the main things. So basically, if you're depending on which business area you're working in, this you basically uh, you will come up with the different critical data elements, right? And and as mentioned, like the normal starting point in a data quality assessment is actually these critical data elements. This is an example, right? So um, date of birth, right? Uh, so it's a, let's assume it's a critical data element, right? And now I'm applying these dimensions or characteristics which we talked about before, right? Is it accurate? Is it valid? Is it on time, complete, or unique, right? And the important thing is that जो हमने dimensions discuss की थी, not all of them are applicable on this, right? So डेट ऑफ बर्थ के लिए क्या चीज़ इंपॉर्टेंट होगी? डेट ऑफ बर्थ के लिए वैलिडिटी इंपॉर्टेंट होगी. इट कंफर्म्स टू सर्टेन फॉर्मेट एंड इट शुडंट बी नॉन null, right? Unique नहीं हो सकता. Is it on time is not important to it. So these kind of things. So this is a basically an important thing that जब आप requirements define करते हैं किसी भी critical elements की in terms of the dimensions available, it's you have to see which dimensions are applicable for that critical data element. Uh, so this is so far basically this is kind of the basic definitions, we like the important definitions which we'll discuss for I wanted you guys to know, like the critical data elements, dimensions, and stuff like that. So next is like I want to start a process, right? I want to improve the data quality, and what's the general process is. As one thing I meant, sorry, I want to mention, this is an iterative process, so it should be backward arrows from the last one to the assessment, but sorry, I forgot to add that. But it's generally an iterative process. So the first thing is like, as I mentioned, like when you start the data quality assessment or improvement, the first thing is you define the requirements of your desired states, right? And once you have the requirements, basically you apply those requirements or rules basically on your data and see what the results are. So it's basically assessment is that part where you apply those requirements or rules you come up with, and then apply them on your existing data sets. And obviously, when you apply those things on any data, right? So the results will be you'll find some issues with the data, and you have to look for the root cause analysis and then resolve why this discrepancy is happening, why this data is not conforming to my rules, and then based on, you have to do the root cause analysis. And the result of root cause analysis, like maybe you have to change the rule itself, or something is actually wrong with the data itself, right? And then once you do the root cause analysis and then resolve those issues, the most important stuff part is like monitoring this whole process, right? And we'll discuss like, and for that you define scorecards and other stuff as well. But with these things, but this is normally the process. Like you define the requirements in terms of dimensions, and you apply those requirements and rules on the data, and then based on the results of those applications, you remove or resolve those issues you have identified, and then basically you go back and let's see how is it. evolving, your process is evolving. So let's look at this, the step one, what you do. So we come out like to come up with the requirements or defining requirements, like or identifying the CDs, like the important one of the important thing or the tool we have in hand is data profiling, right? So data profiling helps you in better understanding of the data you're looking at, and then it also helps you in identifying potentials, requirements or rules that you want to apply on that, right? For example, this is an employee data, right? So we have a employee ID, his name, and his date of birth, right? When I run the data profiling exercise on this, so I say, okay, the total number of records in this data set is 8. Number of unique values 7, and the number of blanks is 1, right? So this is a simple example, right? So based on that, I can define some rules, right? I can say the number of blanks is this. I can see whether which I'll see and go which data element has blanks in it. Are the blanks really allowed, should be allowed in that, or like is it, if it's critical for my success, then maybe the blanks are not allowed. So these kind of things. So these are my things. Generally, they are basically this. There are tools available, like you can use Informatica, Tail and Open Studios. In the big data world, we have Apache Griffin, which can help with that. We have Cerebro as well, which can do these kind of things or help you do kind of things, right? But the idea is that first step is you understand your data, and the profiling helps in that, right? So once you profile the data, right, and you understand it better, and then come up with this, as I mentioned, like the date of birth. Should it be blank? And so maybe this can be one of our rules, right? A date of birth shouldn't be blank. This can be one of our rules, and then we can look at. We can also look, for example, if you look at the row 4, right? So the date is not correct, right? The date format is not correct. So it's 30th February 1968. So this gives another rule that we can define a validity rule, which says that the date should conform to these things. So this is kind of exercise you do in this phase. So next step is like based on the results of your profiling. Basically, you define rules, as I mentioned, like the simple rules, like for date of birth is like must be a valid date from range from 1900 this thing, and the completeness, like it shouldn't be null. So these are basically now this is step 2, right? Now I've defined these 2 rules for my date of birth element, and basically, as I mentioned, like these rules, basically in this case, basically the profiling helps me in coming out of these rules, because I look at the profiling data. I found out that date is null or blank in one of the fields, and I also found out that probably is the range of dates is in this thing, and one of the dates is not correct, right? So that gave me some initial set of rules which can help me in starting this process. So important thing is like you define the rules, and then the rules are defined for each critical data element, right? So you define a certain set of rules. So each data quality rule is set of particular dimensions, right? So these kind of things, and then you can have multiple data quality rules basically for each data element. For example, in this case, we have 2. It's validity and completeness, right? So once we have defined these rules, the next step is to apply these things, right? Apply these rules in there. So now if I apply these rules on my data, so this is the results I get, right? So for validity, I say it give me 6 records pass, 2 fails, and for the date of birth, basically, or for the completeness, 7 pass, 1 fails. So it's basically this is the report, and the important thing to remember, like this score, right? 75%, 88%. So this score is important. I will discuss this further as well, but this is the score of like the score tells you the quality, right, of your data, right? So it means that in this case your data is 75% of your data is conforming to validity rules, and 88% of your data is conforming to completeness rules, right? And the important thing is this score, you can store it in data catalogs, right? So the normal process is like if some like business analyst or a machine learning person or anyone who wants to do some business intelligence reporting, he wants to come in and look for data in his in your data lake, right? So you provide them some data discovery functionalities. So one of the things like used for data discovery is like there are certain tools like so data catalogs are one of them, right? Where you provide like a kind of what is give them like what data is available in your lake, what's the structure of that data is, and basically what fields are available, like and definitions of all those fields, those kind of things, like kind of the schema of your underlying data which is in there in your lake. And people normally, instead of finding directly into there, people normally search in the catalogs. They find, okay, I'm interested in for example this particular sales data from this department, so where can I find it, right? So they search for that, and then based on that they can find this like say a department X sales data is placed under this directory, and if you start storing these scores in the catalog as well, they will immediately know that the department X sales data, basically the quality of that data is good, bad, or whatever we can define that, but like in terms of scores you can say 75% of sales data is conforming to your specifications and 88%. Then they can decide like whether it's good enough for them or not, or they want further improvements or not, right? So but this is the idea of the score, is like you can find it. But the assessment basically when you apply the rules and then on this data, this is the kind of results you get during your assessment phase. The next step is like you have to figure out like why the failures happen, and you have to resolve them, right? This as in any like software development process, right? Testing phase or something. So in this case, like when we did the root cause analysis, we found out that the date of birth, like for in row 4, is not valid, and one of the person doesn't have a date in it, right? And it's basically now once we did the root causes, we can either like fix it ourselves here, like in our ingestion pipeline, right? Something like this, or not ingestion pipeline, but in our data, right, with in our lake itself, or we can basically ask the source team to fix it at their end as well, right? So it depends like what process you want to follow. But the root cause, when you in this resolve data cause issues, this is the kind of the conversations you have among your teams as well as with the source teams as well, like who will fix this data, right? Ideally it can be fixed in lake as well, but because you can fix it in lake as well, but ideally should be fixed in the source, because you'll constantly getting this threat, right? There's a constant feed or daily feed or end of day feed coming in. So if you don't fix that source, basically, then every day you have to go and fix it in your lake as well. Or other option is like you can start applying these rules in your ingestion pipelines or your ETL pipelines as well, right? Or ETL or ELT pipelines, whichever you want to follow. But then when you start applying these rules, so you have to modify your ingestion pipelines a bit. So because whenever these any data which fails or which fail to meet these criteria, right, you have to store it somewhere for further analysis. Like you have to do this exercise, right? Why that data is failed and stuff like. So you have to, in case of a streaming ingestion pipeline, you have to come up with some dead letter queue thing where anything which any data which is not conforming to the rules you applied on ingestion pipeline is stored somewhere where you can evaluate it later on. You have to constantly monitor this process. And the reason, as I mentioned, is because this is an iterative process, right? You'll not get everything right in the in the first phase or like when you do it first time. You have to improve the quality iteratively, right? Slowly and iteratively, right? For example, as I mentioned, because of the amount of data you are dealing with, you should start with a small data, right? So you identify the critical data elements. Maybe you within the critical data elements, you basically identify which one are more important, and then like have a priorities there, and then fix those first one, and then in the second phase you basically fix the lower one, and then but it's a continuous process. And as you bring in more sources of data, so this will end like this will be a never-ending or exercise. You have to do whenever a new source of data comes in. You have to apply these rules on that as well, and identify these issues and fix these issues as well, right? So this is a never-ending process, right? So you have to get some feedback, like whether your process is working or not. You have to monitor that process, right? And one of the things in the when you want to monitor data quality is actually these scorecard metrics, which we talked earlier about. Is that so? What these scorecard metrics helps are that basically it gives you an overview of overall quality of your data within your data sets, and then you can have a trend, a long view or a trend. You can see at the trend whether the process is whether the process is improving the quality of your data or not. Like for example, if for example, if you go back here, right? So if the validity is 75%, if it's constantly 75%, right? So it means that the scorecards, like over the months or a 6 months period, will give you an overview that yeah, my in terms of validity, my data like score is 75%. It's not increasing, it's not decreasing. But if it's not increasing, it means like something is wrong, right? You have to go and back and look like probably what are maybe you have to look at something else to improve that, or maybe something wrong with the process we are following, or maybe we are not picking up the right data elements for improving this validity. So this is the idea of the scorecard, is that it gives you an overview of your process, how well it is working. Or if it's like if a completeness is going down, that's a red flag. Anyway, so these basically metrics monitoring your quality process, and the idea is then you should have some, you can put alerts on these metrics as well, right? So if it's if the data is not within certain ranges, you can put alerts on that for if it's going down constantly, right? If it's below, let's say 80% thresholds, you can set an alert that, and then whenever it goes there, the team is notified that uh, the, the quality of for certain, like for the completeness for this table or data set is going down. So which means like you need to look at why it's going down. You need to investigate. So this is the same idea of the scorecard, which I mentioned. It's just a graphical representation uh, uh, of this profile of your scores, and it's an important tool to measure the data quality process. So I just like this is an example, right, of a scorecard, like how the scorecard reports looks like. Then you can see, if you look at it, we are again, it's in terms of the dimensions we talked about: accuracy, completeness, and conformity, right? It's give the information in terms of that, and then it gives an overview, like for this data set, CDAC or CPE, what's the quality of the data in terms of these characteristics are, right? Um, and as you can see, like, because it gives you a trend as well, so you know how you're doing in terms of quality, right? If whether your process is improvement, or in case of if process is fine, but maybe you need to look at include more data elements to improve it. So these are the kind of things basically. It gives you an overview of that. uh, so I think uh, that's basically it from my side. So it's kind of, this is a overview, basically a small overview. Is that there are other like things we can discuss, like the roles involved in these kind of things as well. Uh, but I think I thought that would be uh, much more time consuming, because there are several roles involved as well. So it's not like who will do this, what kind of work. There's a what's the responsibility of a developer in this process? What is the responsibility of data steward in this process? Who will be data owners? But that's I think that will be a separate discussions, because the roles are defined by the organizations themselves. But the main idea is like the DM box says that uh, there should be a data owners who own all this process, and then with the help of data stewards and the developers, they implement this process and then see how this is working. Uh, but yeah, uh, this is the basic, like just the basic idea behind like how what it means, like how you can measure the data qualities in your applications, or not in your data sets.